Good morning, class. Today we will understand about what is Nyquist rate and Nyquist interval. Now we will start our discussion with the revision of the sampling concept we studied in the previous lecture, in which we discussed the case of oversampling and undersampling. In the case of oversampling, we saw omega s greater than 2 omega m. Omega s is the sampling angular frequency and omega m is the maximum frequency component angular frequency. When this happens, you will find the shifted spectrums of the message signal are having the sufficient gap between the two triangles. That means this gap is called as guard band, and there will be no overlapping. So this oversampling case is allowed, and we know omega s is equal to 2 pi by ts, or omega s is equal to 2 pi fs, and omega m is equal to 2 pi fm. Here we are getting 2 pi fs greater than 2 into 2 pi fm. 2 pi will cancel out, so we are finally getting fs greater than 2 fm. So this condition is allowed, and this condition there will be no overlapping, and this is the case of oversampling. Now in case of undersampling, we saw f omega s less than 2 omega m, and undersampling is not allowed because in this case there is overlapping between the two shifted spectrum or between the two triangles of message signal. Therefore, when we try to recover the message signal or original signal from the sampled signal, it would not be possible. Therefore, this is the case, and this sampling is not allowed, and here we will get fs less than 2 fm. And we saw one more case in which the shifted spectrum of the message signal was touching. In this case, the message signal spectrum was touching. In this case is also allowed because in this there is no overlapping, just touching the two triangles, but there is no overlapping. So we can recover the message signal from the sampled signal, and here we can say that omega s is equal to 2 omega m. Here also fs is equal to 2 fm. So this fs is known as Nyquist rate. So remember, fs is equal to 2 fm. And to calculate the Nyquist interval, we will simply use the relation between the frequency and the time period. We know time period is equal to inverse of frequency, that is 1 by fs, or ts is equal to 1 by 2 fm, and this ts is called as Nyquist interval and fs is called as Nyquist interval. And in questions they will ask you to calculate the Nyquist rate. This means you need to calculate fs, and if they will ask you to calculate Nyquist interval, then you need to calculate ts. Now both the parameters will be found out after calculating the fm. Fm is the maximum frequency component of the message signal. To understand this, let us solve one example. So in this example, we need to find the Nyquist rate and Nyquist interval of the following signal. Signal is m of t is equal to cos 100 pi t plus 2 sin 200 pi t. So in this question, we are having two frequency components, and to find omega m, we need to find the maximum frequency component. So let us understand how we can solve this problem. Let us say the message signal m of t is composed of two signals. One is x1t and second one is x2t. So compare this equation with the following original example signal, that is m of t. So x1t is equal to cos 100 pi t and x2t is equal to 2 sin 200 pi t. And comparing it with standard cosine signals that is x of t is equal to a cos omega t, and for sine signal x of t is equal to a sin omega t. So comparing these two equations with the standard cosine sine functions, we obtain omega 1 is equal to 100 pi and omega 2 is equal to 200 pi. So see these two values for omega 1 and omega 2. We can say that omega 1 is less than omega 2, and through this we can obtain the value of angular frequency. We will find angular frequency 100 pi in first case and 200 pi in second case. So first case omega 1 is equal to 100 pi and omega 2 is equal to 200 pi. Now comparing these two, omega 1 and omega 2, you will find omega 1 less than omega 2. And we are looking for the maximum frequency component, that is omega m. Now out of omega 1 and omega 2 is the maximum frequency component. Therefore omega m is equal to omega 2 is equal to 200 pi. Now angular frequency is in the form of radian per second. The units of angular frequency is radian per second. Now we have omega m. Now we can calculate omega s, or we can directly calculate fm. Fm is equal to omega m over 2 pi. Omega m is equal to 200 pi over 2 pi is equal to 100. Now frequency fm is in hertz. The unit of frequency is hertz and angular frequency units are radian per second. Now it is very easy to calculate the Nyquist rate, that is Fs, because Fm is already calculated. Now Fs is equal to 2 Fm, that is equal to 2 into 100 Hertz, because Fm is 100. So we obtained the value of Fs, that is 200 Hertz. Now second parameter that we have to calculate, that is Nyquist interval. Nyquist interval Ts is equal to 1 by Fs. Fs is equal to 200. That means 1 by 200 second is equal to 0.005, or we can write it as 5 milliseconds. And that is the problem related to Nyquist rate and Nyquist interval. Now our next topic is properties of Nyquist rate. Now let us start with the property number 1. In property number 1, we will understand the effect of time shifting on the Nyquist rate. For that, there is a message signal m of t is having a Nyquist rate fs, or we can say having a Nyquist rate omega s. This property will remain same for both the frequency, whether it is fs or omega s. Mt is a message signal or time domain signal. If we perform the time shifting operation on m of t, we will have a time shifted signal mt plus minus t naught. The first case, which is mt plus t naught, is the case of left shifting. We are having m of t towards left by t naught. Second case is mt minus t naught, is the case of right shifting, or we can say delay. We are shifting m of t towards right by t naught. And in both cases we are getting the Nyquist rate that is same, which is fs or omega s. So time shifting will not have any effect on Nyquist rate, so it will remain same. And this is because the frequency does not change when you perform the time shifting, or we can say that the shape of the waveform will not change. So Fm or omega m will remain same. So Fs also remains same. Now we will move to second property. Now second property is time scaling property or time scaling operation. Again a message signal m of t having a Nyquist rate fs. Now we will scale the message signal by a, that is MAT. So the old Nyquist rate is fs is getting multiplied by the amount by which we are performing time scaling. Let us suppose we have to scale the signal by 2, that is m into 2t, m of 2t, then its Nyquist rate is 2 into fs. A is the amount by which we are performing the time scaling. Now in our example we are scaling by 2, then Nyquist rate is 2 into fs. Now let's move to third property. In third property we are having the message signal m of t and having the Nyquist rate of message signal as fs. In this case we can see that if we want to find out the Nyquist rate of m of t raised to power n, power is m, then the old Nyquist rate is getting multiplied by the power n. Let us suppose n is equal to 2, then the Nyquist rate is 2 into fs. And another example is if we have the value of n is 1 by 2, that means m of t raised to power 1 by 2, then its Nyquist rate is 1 by 2 into fs. Now fourth property is differentiation. We will perform differentiation on message signal m of t. Again, if we have the Nyquist rate of message signal f of s, then we will obtain, or we will have to find out the Nyquist rate of d by dt of m of t, or we are performing one time differentiation on the message signal and we will get Nyquist rate fs. So there is no effect of differentiation on Nyquist rate. Next property is integration. Again, if we have the Nyquist rate of message signal f of s, and this time we will perform the integration of the message signal. So like differentiation, this time again Nyquist rate remains same. That is the property of Nyquist rate of integration property. Now last property, this property is very important. Along with this property, third property is also very useful. Let us take two message signals. One is m1t and second one is m2t. The Nyquist rate of m1t is fs1 and the Nyquist rate of m2 is fs2. We are having another signal m of t, that is the product of m1t and m2t. Now in this case, if you want to calculate the Nyquist rate of m of t, Nyquist rate of m of t is fs and the Nyquist rate of these two product signals, multiplier signals, is equal to fs1 plus f2 not multiplied. That means when two signals are multiplied, then their Nyquist rates are added up. And this is all about the properties of Nyquist rate. Now I hope in this video you understood about the Nyquist rate, Nyquist interval and the properties of Nyquist interval. Thank you.